All right, we are still talking about scatter plots today, and yesterday we talked about lines of good fit that we made by hand, and they are good predictions, but they're not the very best prediction we could make. So to make a line of best fit, we have to use the graphing calculator. So here it says graphing calculators use a method called linear regression to find a line of fit we call the line of best fit. So really it's taking all of these factors into account where it's finding the exact center of our data, where everything is as close as it could possibly be to that line, where it's in the center as best as possible. So it's using linear regression to find that line. The graphing calculator also gives us an R value that tells us the correlation of our data. So let's talk a little bit about that R value. All of our R values will fit on a scale somewhere between -1 and 1. And the closer to 1 or -1, the better, the stronger the relationship. So we'll see a lot of 0.999, 0.998, things like that. That's a really strong relationship. So if it's close to -1, it's a strong negative. If it's close to 0, there's no correlation. It'd be one of those graphs where it's all over the place. And if it's close to +1, it's a strong positive. So I'm going to go ahead and draw a sketch, I think, over what these might look like. So no correlation we talked about is just kind of everywhere. Strong positive is where all your data is a lot more clustered together, a lot closer. Strong negative would be the same. A lot of data and it's really closely clumped together. Where it's more in the middle here, like -0.5, it's going to still be negative, but it might be just a lot looser of a relationship. Same for positive. You can still tell it's positive, but things are more spread out. Okay? So that's what our R value is telling us. So we're going to do an example together using our online graphing calculator Desmos, and we're going to talk about what all these values mean, and we're going to let it calculate the line of best fit for us. So here it says the table shows the duration in minutes of several eruptions of the geyser Old Faithful and the time in minutes until the next eruption. So it's showing how long the eruption is and then the gap between eruptions. Using a graphing calculator, we're going to find an equation of the line of best fit. So we'll just go ahead and pause there. We're going to do that part first. So I tried to put this link as many places as I could think of. So it's above your notes today. It should also be linked in the module. But we want this specific Desmos link because this will take us straight to the linear regression. If you go just to desmos.com, it won't take you to the exact spot we need. So make sure you're using this one. If you click on it from Canvas, you should be A-OK. All right, I just rearranged things so that I can see both windows easily. So I'm just going to type my table they gave me into the one on Desmos. So that when you click that link, it'll always already be filled in with this same table. They use the same one every time. So you are just replacing the data they have in there with your data. So like I have 260, 3.783. And you want to be careful because this one is sideways. So this is going to be my left column. This is my right column. And I'm just hitting tab in between each one to make things move a little faster. All right, so I should have all my data in here. I have 8. And 8. So I didn't skip any. And if you had any extras, you could just backspace them out. And then I'm going to make this bigger now that I don't need that table. And I'm going to zoom out so that I can see my points. So here I can see my scatter plot. And I can see this orange line is running through the middle. That's my line of best fit, this line in orange. So if I scroll down, this is telling me all the stats about that line. So my slope is 11.9901. My y-intercept is 35.1068. So we cannot get that specific by hand, but a graphing calculator can get really nice and detailed. It's saying our R value is 0.978 and our R squared value is 0.96. So let's talk about all of these things. First, let's write the equation. That's what they asked for part A. So I've shifted my windows here again so that I can easily see both. But my slope, let's round to the nearest hundredth. Did it specify? It didn't specify, so we'll use the nearest hundredth. I'm going to have y equals 11.99x. So I'm rounding to 2 decimal places, plus 35.11, because that 6 will round us up here. So that's my equation. It says then plot the data and graph the equation in the same viewing window. We don't have to do that because we use Desmos and it does it for us kind of all nicely in one pane. But if we used a more standard graphing calculator, then we'd have to make it where you could see this information and this picture at the same time. But we don't have to worry about that part because we use Desmos and it put them together for us. It says, part B, identify and interpret the correlation coefficient. So our correlation coefficient is our R value. And it is 0.98 if I round. And then when we interpret it, this is a strong positive. It is very close to a positive one. I didn't ask for this part, but I want to go ahead and talk about what R squared means. So here, R squared would be 0.96. That means this line is 96% accurate at predicting future data. So if I plug in something for X, whatever I get out for Y would be 96% accurate. Interpret the slope and y-intercept of the line of fit. So remember we talked about slope is y over x. So this would be time between eruptions over duration. So we would say there's about 12 minutes between eruptions for every 1 minute of duration of eruptions. And then y-intercept would be whatever the 0 is. So if there is no, like if there was no eruption that didn't last at all, we would expect about 35 minutes between eruptions. If it was like the shortest possible, we would expect about 35 minutes in between eruptions. All right, so really these graphing calculators are finding the very, very best possible line for us instead of us doing it by hand. And then we should be able to identify what R and R squared mean. You do have a big ideas assignment to work on today.